What about covalent bonds? Covalent bonds occur when we're sharing, or atoms are sharing, two or more of their valence shell electrons. So they're not just giving away an electron here or gaining an electron. They're actually going to share with another atom two or more of their electrons to make themselves more stable. And that'll make the other element more stable. So it allows two atoms, at least, to fill its valence shell, at least some of the time. And so you have to realize these electrons are constantly orbiting around the nucleus, right? So it's kind of this constantly moving thing. Now, this can happen with two atoms interacting and sharing two or more of their own electrons. Or in this case here, we have the carbon atom, which again only has 4 valence shell electrons. He would be much happier if he had 4 more. So he can make lots of different combinations. In this case, we show that each hydrogen atom has 1 electron, right? And so if the carbon binds with 4 separate hydrogen molecules, then it's going to make its valence shell happy by having 8 electrons filling its valence shell, by sharing 4 of those with 4 hydrogen ions. And this CH4 is actually methane gas. All right, so I want you to watch this video so that you can get a better idea about bonding. It's listed in the resources under Part B of Chapter 2. To give you a better idea of what happens with different atoms that have different electrons in their outer shell, we can look at oxygen. Oxygen has 2, 4, 6 electrons in its outer shell. It would be happiest if it had, and most stable if it had 2 more. Well, it can join with the oxygen atom, another one that has 6, and the 2 of them can get together and share 2 electrons. And this makes actually what we call a double bond. When you're sharing more than 1 electron, you make what we call a double bond. So a double bond is when you've got 2 electrons being shared between these molecules. And then if you've got 3 electrons being shared, like we see here in nitrogen gas, to help fill that valence electron shell, then you've got a triple bond. So that's a triple bond. Another aspect of covalent bonds that you need to learn about is called covalent bonds. We have polar and nonpolar covalent bonds. An example here is carbon dioxide. A nonpolar covalent bond means that there is equal sharing of the electrons between the atoms. All right? And so this is nonpolar because it's so equally shared that you don't get any, it's like a straight line, if you will. That's how we draw it. So it's balanced and there's not any abnormality. Now, water, on the other hand, is actually got polar covalent bonds. And the reason for this is that the sharing of that 1 electron with the hydrogen ion with the oxygen is actually not going to be shared as equally, and it has to do with the attraction properties of the atoms. And so it becomes polar. Basically, what you need to know is a polar molecule, or a molecule that has polar covalent bonds, has a net charge on one side of its formation and the opposite charge on the other. So on this side, in water, you've got a net positive charge on this side, and that's because those hydrogen ions are not equally sharing their electron with oxygen. And then you have a net negative charge on this side, where the oxygen is. And when you compare this to carbon dioxide, there's none of this unequal sharing. The oxygen is sharing 2 electrons with carbon very happily, and then this oxygen is doing the same. And so there's none of this partial sharing that generates charges on either side of the resulting molecule. What you can do to reference these different types of bonds is look at this chart I have here. This essentially is going to show you, as a reference, strong bonds into a little bit less strong bonds, or less reactive to more reactive. So you could call these stronger to a little bit less strong. Okay, and vice versa. So the ionic bonds have a complete transfer of electrons. They are giving over or completely taking in an electron. They create separate ions that are charged particles. So we have anions and cations. Sodium chloride is our example. In a covalent bond, we have two types. And remember, this is where electrons are being shared. In a polar covalent bond, you have this unequal sharing of electrons. So you end up with a slight negative charge at one end of the molecule and a slight positive charge at the other one. Water is an example of this. Why this charge on either side matters to us is because it's going to determine how this molecule relates to other molecules. So you need to keep that in mind. And then in nonpolar covalent bond, there's an equal sharing of electrons. The balance is charged amongst the atoms. In our example with CO2.